Hey guys, happy Friday. If you missed your live learning class, this is the video for you. I'm going to go over what the slides were today, what we did in breakout rooms, and I'll just explain to you what your independent work is. It is Friday, September 25th. This is when this lesson is. It's not the day I'm filming this. Our title today is Pressure. The model below shows what state, the model below shows what state change happening. How do you know? This is based on what we did yesterday. So here's a model looking at the before, the after. You're looking at the particles, looking at their spacing, looking at their arrows, trying to figure out what state are these in. And this is one state. This is a different one. You might pause this video in a second and say, I know the state change happening is what? Evaporation, melting, freezing, all the other ones. Which one is it? Because, etc. Okay, don't forget. On Wednesday, I assigned you your homeschool connection number 2, and it's due Sunday. If you haven't had a chance to do it yet, do it. You're going to have a conversation with an adult in your house about the questions. You will find that linked on Wednesday's lesson from this week. That would be lesson 7, L07, climate change and chemistry. I have a quick scientist of the day for you. We're going to go over our learning target. Actually, learning target's down here. I'll go over the breakout rooms with you, and then I'll go over your independent work. This is Baruj Benacerraf. He passed away in 2011, so you might be able to do the math. Tell me, how old was he when he passed away? He was an American immunologist. He was born in Venezuela, so he's a Venezuelan citizen. But his parents were from Morocco and Algeria, and they were Jewish. Oh man, that is a whole thing. So he was Moroccan, Algerian, Jewish, born in Venezuela, and became an American. Whew. So he moved to the United States when he was 20 in 1940. He graduated from high school and college and got his MD, his medical doctorate, from the only school that would admit him because he was Jewish. Back then, being Jewish meant you wouldn't be able to go to a lot of schools. He was a medic in the Army, and he eventually joined Harvard Medical School, and he worked there for a long time. And in 1980, he won the Nobel Prize because part of his research was he discovered proteins on the outside of cells. Now, I know you guys learned about cells last year. And so he discovered these proteins stuck on the outside of cells. That is what the immune system knows they're your cells. So the immune system will not attack, we have the white blood cells and the antibodies. They don't attack your own cells normally unless you have an autoimmune disease. But normally they can tell, like, oh, hey guys, this cell is Mr. Murphy. Let's not attack that. Oh, wait, but that maybe is a bacterial cell. We need to attack that one. We don't like that one. And so they know that because of this protein that's like a little signal on the outside of cells. And our scientist of the day was the guy who discovered those, and he won a Nobel Prize. Pretty cool. Okay, so today in your breakout rooms, so let me just show you what you're doing, what our students did. They opened up this slide. It takes you to a place that looks like this, and I'll go over the examples with you. One person shared their screen, and you had to discuss these scenarios and basically make a model together as a group. And let me show you how I would have done that. And so let me just, let's see, can I exit out from the presentation? Yes, I can. So this is the example. This is the same one that we used for the do now. This says condensation actually was the answer to the do now. This is fog on a bathroom mirror. Before, it should be a gas. I'll write that in here. And after, it should be a liquid. Okay, so this is what students are doing. This is my example, but students are doing the same thing in a group. So then I'm going to look down this particle bank. I'm going to say, okay, I need to make this look like a gas. Okay, so I'm going to take a few more. I can copy and paste these. I'll just copy paste. I'll get like 3, and then I want long arrows, and I can either click on this arrow and copy paste. And the directions they're moving are kind of random. They're not all moving in the same direction. So I'm just going to take these arrows, kind of point them in random directions. Okay, but I can tell they're gas because they're moving really fast because they have long arrows. And because the particles are so separate that there are only 3 of them are in the picture. So now over here, these should be liquid particles. And now I'm just going to show that they're liquid, I'm going to copy and paste some of these arrows and particles and just flip them around. And they should be somewhat close to each other, closer than a gas. not as close as a liquid, or sorry, close, not as close as a solid. Thank you, those of you who are yelling at me through your minds. I heard you. So I'm just going to take these. I'm going to try to randomly place their directions, something like that. Maybe one more this way, pointing up, something like that. Now this looks to me like liquid particles because they're moving around. They're not like solids lined up. They're not just vibrating. If I wanted to show them vibrating, I would use this line, and that molecule is now vibrating only, and I could maybe do 2 of them to show that they're vibrating a lot. But these particles are moving around. That's what the arrows are, randomly. They're a little bit more spaced out than solid particles. This is a gas turning into a liquid, which happens on your bathroom mirror when you take a shower.
Officer Stefan, please go to the...
Okay, we'll keep going. Sorry about the interruption. I am at school today while I film this, you can tell. So this is what students are doing. So if you were in breakout room 1, you did evaporation. If you were in 2, you did melting. If you were in 4, you did freezing. 3, you did sublimation. If you don't remember what that is, look it up. We did it yesterday. If you miss live class, pick one, make the model. It helps for you to physically make it. If you were in live class, like actual class, if you were in my classroom with me, I would be making you model these things every day. It's a lot harder to do that on the computer, a little more tedious. So practice now. Here's where your independent work begins. In independent work today, you're going to be predicting a change in pressure in a closed system based on the change in particle motion or state. So I'm going to tell you that the particle motion is changing and asking you, how does the pressure change? You're going to have to predict that for me. A couple of 3 academic language vocab things I have for you. Temperature, I think I've introduced this to you, but so to remind you, is the measure of the average kinetic energy of the particles in a substance. Okay, so how fast they're moving. Some particles might be moving faster than others, but the average is the temperature. Okay. Closed system is like this one on the right, is a physical space or container that does not let particles in and out. And so a thermometer you might choose as a closed system. The bottle and balloon that Ms. Beatty made the Ed puzzle about is a closed system. Particles aren't entering and leaving, they're just moving around inside. And that's what we're talking about today. And then finally, volume, the amount of space an object takes up. You can look at this pictures to kind of think you can measure volume of a liquid. Here's my water bottle. I got how much water, the volume of water. How about this? There's a picture of the Avengers, the original 6. Can you tell me which one has the greatest volume? Great. Let's keep it moving. Okay, so for this first part of your independent work that is like actively doing something, you're going to open up this. You're going to click here and you're going to open this simulation, or click here. It's the same thing. You're going to click this phase change box, take a couple minutes, play around, and then click on neon and reset. Slowly heat the solid particles to about 25 Kelvin. You can see the temperature up here. That's temperature. I should label that. I will. What happens when the pressure increases above 0? So the pressure will be at 0, and I want you to just carefully watch what's happening as you slowly heat up a little bit until it's just 25. So you're only heating up a little bit, and then wait and see if the pressure will increase, and then go, wait, I saw that. That's the reason the pressure increased. And then answer these questions. So number 7 is repeat what I just told you to do, the adding heat until it's at 25 Kelvin. What happened? What did the particles do that made the pressure go above 0, that gave it some kind of pressure in the jar? Finish the sentence that tells me that. To make the pressure increase, the particles are doing what? Okay, then play around with all the different things you can do. Can you find at least 3 ways to increase pressure? You can change the pressure. Different ways to change, or basically if it starts at 0, you have to increase the pressure of this closed system. Find them all for me. And then try to make the lid pop off. That's kind of fun. How'd you do it? Why does a lid pop off? Finally, how does any of this have to do with popcorn popping? Finish that sentence for me. The idea of pressure can help explain why popcorn pops, because start making that connections. Okay, and then you have your exit ticket. I got 2 containers. I got container A. I got container B. Container A is at 250 degrees Celsius. It's pretty hot. Container B, 500 degrees Celsius. Does container A or B have a higher pressure? Why? Tell me by talking about particle motion. So I think container A or B has a higher pressure because the particles are what? That's what you're doing right now. That is all. That's it. Make sure you turn in your homeschool connection number 2 by Sunday. I hope you guys all have a fantastic weekend. Check your grade on Student View. If you are not happy with it, you've missed some of the quizzes probably. Figure out which ones you missed, go back and do them. Okay, probably from last week or even this week, I've now graded 3. There might be more coming soon. The only way to fail them is to not do them. So get them done.